About a minute to go. Hello, hello.
Hello, can you hear me?
Yeah, we can hear you
Excellent.
great. Awesome. And I see your screen share, so I'll be able to add that in a moment. Alex Willmer. So there's no bio on the website. Are you anonymous or?
No, just probably forgot to fill it in. Alex Willmer, I go by Moriarty in a few places. Chose the name ages ago. Just stuck with it. I'm a Python developer, Ansible developer for a company called CGI. Nothing to do with computer graphics or web servers. We just do IT consulting. Scanwalk is slightly the result of working with Ansible and trying to accelerate copying lots of files.
Fun. So before I add your screen, what's in the what's I'm just kind of curious what's in the mug if you're going to be drinking something hot to warm up. What are you going for?
Just generic cola.
Okay, there you go. Pepsi or Coke? Not to start a war.
Technically, Pepsi, I suppose, but it's like those soda stream things that you buy the syrup and then you add it to stuff you've squirted with gas.
There you go. So artisanal. It's artisanal cola.
Okay.
Because you're doing it yourself, therefore it is artisanal. Branding. All right. Well, Alex, take it away.
Okay. Thank you very much. Hi, my name is Alex. I am from the UK. I do Python development and big data with a tool called Ansible. In doing that, ran into some very large directory trees that needed copying around, and by a circuitous route came to write this package called scanwalk. It's still in alpha phase, but the idea behind it is that it is an alternative to the built-in Python standard library function called os.walk. Does the same thing as os.walk, just presents the results in a slightly different way, which I think is more Pythonic, if I can be so bold. So the idea is here, live demo time. Hopefully the demo gods are with me. So standard Python 3, import the OS module from the standard library. And if I want to look at the contents of a directory, I can do for parent, there's files in os.walk demo. Then I need to do an extra layer of iteration here for the in DIRs. Oh, frig. Can't type. Bear with me 1 second. And that will print out the contents of this demo directory, just to give you an idea of what that looks like. A couple of directories called dir1, dir2, and inside dir1 we've got 1.1.2 and some files. If we want to do the same thing with scanwalk, which is the package I'm presenting about, then we can use one that I installed earlier. There we go. So the difference between os.walk and scanwalk.walk is that whereas os.walk returns these tuples of parent, what directories are in there, what files are in there, scanwalk.walk returns a flat iterable of dir entry objects, and dir entry objects have attributes such as the name. So the name for each of these, that would have been dir2 or dir 1.1 or file A, and they also have the complete path. So this makes scanwalk easier to use in situations like list comprehensions. If I want to, I can do and it's just quite convenient to walk an entire directory tree and get a list of the paths. This is a bit more awkward to do with the built-in os.walk function. So that is the essence of scanwalk, and the reason for its being. Those of you that have used the standard library function os.scandir will probably recognize these dir entry objects. And as you rightly guessed, scanwalk essentially is a thin wrapper around the os.scandir function. So os.scandir comes with Python out the box, part of the batteries that are included. It returns these os.dir entry objects, but os.scandir just works on a single directory. It doesn't walk an entire directory tree. That's essentially the point of scanwalk. It is os.walk if it had been implemented after scandir existed. Now, scanwalk is currently a pure Python package. What that means is it will work anywhere that Python works, but it is not as fast as it could otherwise be, and it has to do a couple of underhanded tricks in order to work within the confines of what os.scandir allows. So as an example of this, if I, instead of building my list of things, I build it with the actual dir entry objects using the currently released scanwalk, which is pure Python, we see a bit of a cheat. The first one, the one that represents the directory itself that we're walking over, is this thing called a fake dir entry. And that's because it's fake. The others are the result of running os.scandir. But because of sensible restrictions on the os.scandir function and os.dir entry class, pure Python can't make its own dir entry objects. What I mean by that is if I import OS and if I try and make os.dir entry object, I'm not allowed. And that's an intentional behavior of Python. It's a design decision and it's a sensible one. But to get past it and to be able to have a single, an object that is the same across all the elements in os.walk, it's necessary to drop down to the C level. And that's what I've been experimenting with and what the remainder of this talk will be about. So, the first attempt to do this was to take POSIX module.c from Python, from CPython, the default implementation, find the parts that implement os.scandir and just copy and paste effectively. So POSIX module.c is a large file. It implements a lot of the stuff you see in the OS module when you're running on Linux or Mac OS. And the scandir parts are just a small part of it. The attempt to do that is not in any released version of scanwalk, but it does exist, as do the others, as branches of the scanwalk repository on GitHub. I was feeling whimsical that day, so I called it Franken POSIX module, because I'd just taken parts of POSIX module, ripped them out, stitched them together, and tried to make a shambling beast. This is a Frankenstein's monster of how you would write a C extension for CPython. You have the full flexibility. This is using the raw Python C API. And if you are just trying to, you're just trying to make a small extension to an existing Python library that happens to be written in C, this is a reasonable way to do it. But you do suffer certain restrictions in that parts of the Python standard library are written in the knowledge that they are part of Python, so that they can take certain shortcuts that a external C extension can't. And this has the full flexibility of the scandir implementation that is in CPython, but even just the bits for scandir come out at 2,500 lines. It's quite a lot to understand and to tweak, and if you wanted to maintain it across versions, it would be somewhat of a maintenance burden. So if you need the absolute flexibility you can use the Python C API, but you will be tied to CPython, which is the default implementation from python.org. You will find it a harder time to make this available for other implementations of Python, such as PyPy or Cython or others that are springing up. So this was my first attempt. It still I'm still referring to it, but it is unlikely to be the design that I will be going with. The next attempt uses a package called CFFI. This is available on the package Python index, and it is come out of the PyPy project. So that's the Python on Python people, PyPy. It has the advantage that what you are writing is mostly Python. You're not writing much C. And it's particularly good if what you're doing is just wrapping some existing C code. So we can have a look at the result of using this. That is the pure Python one that is the current release. That's the dir entry and the fake dir entry. This is what we're trying to get rid of. If we have a look at the, where did it go? There. If we have a look at the CFFI implementation, it is across two Python files. Scanwalk.py is an evolution of the existing pure Python scanwalk.py, and the changes are rather minimal. It still has the fake dir entry. CFFI will allow me to remove that. I have not got around to it yet. But rather than calling os.scandir directly, this is now has its own implementation of the underlying C, its own wrapping of the underlying C function scandir. And the way CFFI works is that your second file, typically called yourthing_build.py, contains a small amount of C declarations. And the nice thing that CFFI does for you is that you don't need to worry about what goes here. The ... is filled in for us by CFFI. And again, here, we don't need to, our cross-platform implementation can be simpler because we don't need to know exactly what size of integer macOS or Linux exposes this type as. CFFI is able to fill that in for us. And these 37 lines are the sum total of the C that you need to write with CFFI. We can see this in action. This is the CFFI implementation. There is an existing virtual env here called v3. If we install this branch here, then we can use Python. Again, this is a different scanwalk that we are importing here. It's not the one that's on PyPI. This is the CFFI implementation of it. And we can see that because there is within it a second module, which is the C library that CFFI built and has exposed. And what this makes available to us is, for instance, this constant here, which is a C hash define, has been exposed, and we are able to use it in Python. Or not. Wrong one. That should be .lib. Still no. What have I... Too many underscores. So that has been pulled from a C header somewhere in Mac OS. I don't need to know where. CFFI has done that for us. The result is that we can take our code from the pure Python implementation and use it without change. Still got the fake dir entry, but that is just because I haven't got round to removing it yet. CFFI allows us to. So that was the second attempt. CFFI it has the advantage that you are writing mostly Python code. You don't need to know much about C, and it's very few lines to get something working, and what you write will be compatible with CPython and with other implementations such as PyPy. The third attempt, which I'm experimenting with, uses a binding technology called Cython. Cython is a hybrid of C and Python. And in fact, you write a file. Wrong one. You write a file with a .pyx extension, and you are mixing normal Python, but also you are mixing imports of C functions. So Py error occurred, Py set from error number with file name object. These are part of the C API that CPython provides, the one from python.org. And these are the ones that are getting used by scanwalk.c. But here, we're using them in a more or less Python file. So we don't need to worry as much about the details of C. And this is probably the implementation that a future version of scanwalk will use, because there are a few things that CFFI may currently make a bit difficult. That may be down to my knowledge of it. There may be other ways to do it in CFFI. Cython, in my experience, gives us the maximum flexibility of the raw C API in CPython, and the cross Python compatibility and conciseness of writing with CFFI, mostly Python. Cython was the sweet spot, at least for me. And if we try this, what has happened in the background is that Cython has taken our .pyx file, made a C file from it, which is this one. This one has been auto-generated for us by Cython. And then we can, just as before, different implementation, same API. We have our list of entries, and fake dir entry is gone. We're now presenting a uniform interface to the rest of the world. We've hidden the nasty stuff that we need to do to make that happen behind the Cython implementation. And we can proceed with the next release. So I think my time is up. Jason, would you like me to hand back?
Yeah, absolutely. And if anyone has any questions for Alex, by the way, thank you so much, Alex. It's really cool to see all the different ways that you can approach actually getting Python to work with C, work with other languages. So if anyone has any questions for Alex, please ask in the either in the live stream or in the Ask Speaker Discord channel. If you ask the next minute or two, I
will be there to answer questions. I'll also be posting links to the package itself and the branches that have been the different experiments to see what worked for me best.
Now, I find it interesting that you didn't mention a lot about performance. Performance obviously is not one of the main goals here, but did you notice anything, because a lot of people think about, oh, let's work with C, it'll be better performance, and that's true in some regard. Did you notice any differences in performance, or is that literally just not a thought on the table for this project?
That was, so I didn't have time to go into it, but one of the things I thought when I initially implemented this was that this would end up being a lot faster, because it turns out that the os.scandir function in the Python standard library doesn't use the C function scandir. It uses a different thing from libc. And I thought by using scandir that my package would be faster. That's not the case. There's a long thread about why that is on Twitter, and again, I'll post a link to that in the chat. As it stands, just because we're not building as many lists, scanwalk, under certain circumstances, is about 10% faster. But frankly, that's neither here nor there.
I guess it just goes to show the value of the old adage that all performance is mythological until proven otherwise.
Indeed, yes.
Excellent. Just watching here, see if anybody else has any other questions. So I guess one other that I would have would be, at what point did you get the thought this should be a library? Because I think a lot of people feel a bit of hesitation because they're told, we have the saying, don't reinvent the wheel. And so people tend to, at least starting out, tend to be a little more hesitant to create libraries, and then they gain more confidence, think I can actually do this better. When did you decide that this was worth turning into a library?
So over the last couple of years, the interface of os.walk had niggled me slightly. I quite like using list comprehensions, and the nested nature of the tuples that os.walk returns makes that slightly messy. And there was os.scandir sitting in the same module that has quite a nice library. Eventually, why not glue these two together? Experimented, quite like the result, and have released this. It is still very alpha. There is a lot more to making a package that you can just say to people, use this, it's better. But it is the way the world moves forward. So sometimes reinventing the wheel is a good thing.
Excellent. Thank you. And then when this becomes as ubiquitous as Pathlib, we will say we knew you when.
If.
I have confidence in you.
Thank you.
All right. Thank you so much, Alex. So Alex will be hanging around the Discord. If anyone has any further questions, then he'll be